I am going to build the network diagram on the basis of given information. Every network diagram which we are going to construct will be having a starting node, and that will be having an end node. So, nodes we are represented by a 0, a kind of thing, that is a circle, and activity we define it with the help of a arrow. So, this is the way we represent activity, and this is the way we represent the node. And these things which are going to be the length of arrow is not going to determine what is the duration of the activity. It is just a symbolic presentation how activities are being linked with each other. To build the network, we need to fix the first thing, that is we are going to have a start with the starting node which is there. So, this is a starting point, and we are going to have activities which are there going to be there, that there are no activities which are starting with before A. So, A and B are the independent activities which are going to start together. So, we having two activities, activity A and activity B. So, every activity will have a starting node as well as having a ending node. So, this is activity A, this is the activity B, and then from activity B A there is going to be another activity which is going to start, that is activity C. So, this activity is going to be there, and then at the same time from activity B there is going to be starting another activity, that is activity D. So, from B I am starting activity D, but at the same time this activity which is starting from E is the activity that from activity C which is going to start is activity E. So, that is where I am joining these two activities on one single node, because from these two activities together, that is activity D, activity E and D, there is going to start another activity which is called activity G. So, activity G is going to start from D and E. So, that is what has been given with us, and from activity C there is another activity which is starting is activity F. So, activity G and F are going to lead to another activity which is called activity H. So, there are basically two models to do the same thing. Some of the approaches are saying activity on the arrow. So, I have used activity on the arrow, but at the same time there are another approach, you can put activities onto the node, that approach is also valid. So, both approaches are fine. So, this is the way we construct the network diagram. After doing this, we are going to plot what is the time which is required for each and every activity. So, management has informed activity A that will going to take a time of 2 weeks, and activity B is going to take 3 weeks, and activity C is going to take 2 weeks, and activity D is going to take 4 weeks, activity E is going to take another 4 weeks, and activity F is going to take 3 weeks, and activity G is going to take 5 weeks, and activity H is going to take 2 weeks. Now, what we are going to do, we are going to name these nodes so that our relationship is being properly defined. So, this is my node number 1 and this is my node number 2. How we do it? We just follow the order of the network in such a way that network relationships are being properly remain defined. So, just like we start from here, we cannot put here 1, we will start from here only 1, that is 1 and 2. The sequential manner is to be maintained, that this is 3 and this is now 4, and because this activity lead to this, so I am not putting 4 here, I am putting 4 here first. So, this is 5, and from here this is I am putting node 6 and this is node 7. So, how we are going to use this particular timings? We are going to now calculate for determining CPM, because this is a deterministic model we have assumed, because we know what is the time and duration of each and every activity. So, we are going to start with what is the earliest starting time by which we can start a project activity. So, project activity can start with, when I am saying earliest, E is earliest start time. So, earliest to earliest, this can be started at the 0 period, that is from where I am starting. Now, to start the earliest to earliest, this activity 2, that is this event will be going to happen only once the duration of this particular activity is finished, that means 0 plus 2, that is 2, but here the earliest start time would be 0 plus 3, that is 3, and at the same time here this particular activity is going to be 2 plus 2, that is 4, earliest start time for this would be 4. Here is something which will be creating a difference. Difference is because this activity, this event is not going to finish just because this is 3 and this is 4, that is 7, but we have to see that from upper side also there is another activity which is coming. So, this particular activity taking 4 plus 4, 8. So, when maximum that this activity can be finished is the event 5 can only finish once we are finished with the both activity, and other activity cannot start before 4 plus 4, that is 8, 3 plus 4 is 7. So, that is making it what is highest? Highest is 8. So, I am going to take it as a 8. So, this is where my I will write when there is a merging events, I will write the maximum value, and now again this is again a merging event. So, what is the value going to come here? 4 plus 3 7, but at the same time this is 8 plus 5, that is 13. So, I am going to write it here as 13, not 7, and finally this event which is going to be there 13 plus 2, that is 15. So, my project is going to be complete in 15 weeks. That was my first question. Management want to know how much time we require to finish our project. They have a deadline of 16 weeks, but we are able to complete the project in 15 weeks. Otherwise, if you total it up all the time, it will come to around 25 or 26. That means, are we going to have 26 weeks to complete the project? No, because there are some simultaneous activities which are going on. So, by which we are able to have lesser time. So, to calculate critical path, we are going to use the same calculation in the backward way. So, how we are going to work? So, backward way is what is the latest finishing time to do this work. So, latest finishing time will be 15, that is we want to finish this project by 15. So, what I will do is when I went for the forward path, I added the things. Now, I am going to the backward path, I am going to subtract the timings. So, this 15 minus 2, that L is equal to, if I reduce 2 from here from 15, that makes 13, but at the same time now if I come to this particular point 13 minus 5, that is 8, and then I come to this particular thing. Now, here it is going to be 13 which is there, 13 minus 3, that is going to be, if I write it here 13 minus 3, that is coming 10, but I will not write here the value. As I told you, when we are going in the forward path, we are concerned about the merging event where the events are merging, but when we are coming onto the backward path, we are concerned about the bursting events from where the 2 or more activities are starting. So, here the 2 activities are starting together, here it was only 1, here is 2 activities are starting together. So, we have to see together what is the late to late finishing time for this particular activity. So, late to late finishing time would be 8 minus 4, that is 4, but here it is coming 13 minus 3, that is 10. So, what I will write? I will write what is minimum value. When I was going forward path, I said maximum value, but I am in the backward path, I am saying it will be the lowest value. So, lowest value is 4. So, I am writing it here 4. Now, come to this particular value, L is equal to going to be 8 minus 4, that is 4. Now, I come here at L 4 minus 2, that is 2. Now, this is again a bursting event. So, 4 minus 3, that comes 1, but 2 minus 2, that comes 0. Again, I write the least value, that is 0. Now, we are going to know what is the critical path. So, critical path is the path where my L and E are equal, and the lines which has made this L and E equal, that is my earliest start time and latest finishing time both are equal. That is a point which is going to be telling me that is activity, that particular activity is a critical activity. So, here L and E equal. So here L and E equal, so that means I am double shading it. So this activity is a critical activity. Here L and E are not equal, so it means this is not a critical activity. And same way, if I move forward, this is another critical activity because L and E are equal because of this. And now I am coming here, what L and E both are equal, but it is not because of this, this is because of this activity. So that is why this is also equal, this is a critical activity. Now from here, this is the critical activity, and finally from here, this is the critical activity. These are activities which are critical. So finally, if I say it that my critical active path is A, C, E, G and H. These are my critical activity. As a manager, project manager, I need to be ensuring there should not be any delay in these activities. So that is the where I need to put my maximum control, and these activity B, D and F, these are activities are non-critical activities where a delay can be possible. How much delays can be possible, we can also calculate, so that these non-critical activities should not become the critical activity, that we can determine with the help of slack. Thank you very much.